Yep.
Good. So we are Cortical.io, this is Soren, Pablo, and I'm Erik. And we came back here to experiment a little bit, combining our retina technology with the CLA. We were here last year, and we enjoyed it very much, bringing the two technologies together. And last year we were working on strict sequences of terms that we fed into the CLA. For example, we said like Max Planck is a physicist and Marie Curie is a physicist, and then the CLA, back then, I named it the CLA, was able to infer also that people they had never seen, like Albert Einstein, were also physicists. And this year we wanted to move away from these patterns and try to feed a network of HDMs with articles about different topics. And the basic idea was to get the network to extract and learn interesting facts from the input, and then to query the network and to see how it goes. And so the data we used was just like manually collected articles from Wikipedia and some blog posts about topics. So we looked at Google Trends and we chose iPhone 6 and Ebola. And we took mostly cities because we thought initially this might be a good idea to use this kind of data with a lot of statements and facts about properties of the cities, descriptions of the cities, to feed this into our HDM network. And what we do on the data pre-processing side is we tokenize the articles into sentences and words, and these sentences and words are then fed into the HDMs. And this is mainly so that we can transform each word into a fingerprint and then feed the fingerprint into the HDM network. And we need the sentences because we think it makes more sense to reset on NuPIC after we fed in one sentence. So the basic outline of what we tried to do, and it looks like this. So we have 3 HDMs that we use. The general idea behind this was that we tried to split the task of understanding facts and then generating the answer to different HDMs. So there's one HDM which is mainly specialized in grammar, and another HDM which is what we call the associative HDM, which should learn to predict on an incoming topic what other noun is associated with this topic. So for Paris it should be France. And the job of the grammar HDM then would be to find out what is the connection between these two items. And so the first step is...
can you make it a little bit bigger, the slide?
Maybe.
Zoom in the top left.
Top left.
That's better.
Perfect. Yeah.
Good. So the first step is to train these two HDMs, and we kind of bootstrapped the training of these HDMs. So each one is fed, the grammar HDM is fed with tuples of noun, verb, or adjective verb pairs. So his job would be given the verb, given the noun like France, it should say France is in Europe if it has seen the sequence. And the associated one is just there to be fed with meaningful patterns, noun-noun combinations, for example. So Paris, France would be one combination. If I feed in the pattern of France, it should predict Paris. And in order to get these two things together, there's a third HDM which we call the memory HDM. We kind of had to introduce something like the simulation of context, because of course different noun-noun patterns can occur, and different noun-verb or adjective-verb patterns can occur. And what we want to achieve in the end is that due to the context, when Paris and France occur together, the memory HDM is able to distinguish between what should be the prediction here. And what we did there was to randomly delete bits from the SDR for Paris, for example, when Paris was the triggering element. Like this, we create different representations, different SDRs of Paris, which for us is like the simulation of context. And then these SDRs are fed, and they all look like Paris, but they all look a little bit different, like different versions of Paris. And this is what is fed into the grammar HDM and the associative HDM. So we have the possibility of having different patterns which lead to different predictions. So we can go from Paris to France, to World Cup, and to other noun combinations with all these different looking Paris SDRs. And then in the end, we can query the memory HDM and retrieve all these different prediction paths. And we had bigger plans at the beginning. So we just...
It's pretty ambitious already.
Yeah, we underestimated it a little bit. We just wanted to bootstrap these and then use things like anomaly detection to identify, for example, one big difficulty that we had is like you can have a combination Paris is in France, France is governed by Paris. So these are very different word combinations and they mean very different things, and if you feed them in a very simple model, just in sequence, then this will potentially not lead to something meaningful. Also because of the input data, we just used the HTML pages and copy-pasted from the Wikipedia articles, so the input data is also very messy. We did not clean that up completely. So, for example, what used to be tables or lists, when you copy-paste that, will create funky combinations. And we thought we can use anomaly detection to detect these inconsistencies. And also to identify things which are surprising. So this is then the next step. You have trained it. It has some knowledge that it extracted, and you could send something in, and this would then trigger an anomaly. And this was like the bigger picture that we had in mind, that you can use this for information extraction. You just feed in some articles and you get the public opinion about a topic. You say like, I want to learn about iPhone. You throw in some newspaper articles, some blog posts, and it will extract the facts. With the anomaly detection of the HDM, that we could identify things like people will always say like the iPhone is great or the iPhone is not so great, and that something like iPhone bends would then be a surprising thing for such an HDM network to see. And then of course from our side, because we have now the cross language, also to have things like learn on French material and then to generate an answer in English. And do we have like 2 minutes to show it quickly?
2 minutes.
Okay, I'll show you fast the example. So this is a train model of the trend Ebola, and let you put a query. I will probably just show you this example. I need predict something about it. So it's not super smart, but we can see here that at least it returns something that it makes sense with what is happening now in the world. If you put again Ebola, expect that it returns something different. It's not super smart. So it's a stock here now that you can ask about more things. And What other symbols do we have there? Yeah, it has something I guess with the case of Ebola in Dallas, so maybe concrete. It's, at the end it was not as we expected, but it has some potential because we could solve, for example, the first is the real what we could expect from the input, but afterwards. So that's it. And if we can solve the other model fastly. The other is the Paris model, and
The what model? Oh, Paris model.
yeah,
Is this the output of the final third HTM, or just?
Exactly. These are just the prediction of the.
yeah, it
third
just
HTM.
fits with the first element, and the HTM.
20.
This is completely messy text, so it basically couldn't learn so much about
Yeah, it's like that book that the guy
And,
sent me.
this was interesting because it about Paris has a lot of occurrences, and it tends to return always different things.
It's not consistent because why?
Because when we fit with Paris and then the other elements after Paris, Paris is always a copy, not 100% of the original Paris. So it will know that then when you input Paris, it will match not with always the same, because we do the same with the input. We remove randomly part of the,
Oh, you moved randomly part of it.
and yeah, that was it.
What if you input Ebola into the Paris model? Ebola. I'm just curious. I'm sorry. Nothing. Nothing. It doesn't know.
So,
Well, that makes
I mean,
sense.
what's your takeaway on this? I mean, I don't know. I don't know. What did you learn that was hard or not hard, or what did how can you judge it?
Yeah, I guess the most difficult here was to interconnect the HTMs, because we tried to do this with randomly remove parts of the input fingerprint, expecting that then it could find both at the same time. But apparently this didn't happen.
Yeah, and also, I mean, I guess we would have needed more training data and more examples, because I mean, the HTM network is completely empty when you start, and we just fitted one article, or in the case of Ebola, I think it's 7 blog posts, which already works a little bit better. But I think one main thing was that we thought when we have better input data, so we have to install kind of like a conceptual basis, that then it might work better. Because the Wikipedia article about Paris, it talks about 100 different aspects about Paris. There's very little repetition. So we thought like this might have backfired, especially in the end when you use the prediction of 1 or 2 HTMs to feed into the third.
Yeah. You need to see a lot of repetitions of the same semantic transitions.
Yes.
Right? And with one article, just like you said, you're not going to see that many.
Yeah.
Cool.